Microsoft just dropped a big announcement at Build. Stand by for news. Welcome to this video on Microsoft Fabric. My name is Kevin Fiesel. I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. We are interrupting our regularly scheduled video broadcast to look at Microsoft Fabric, Microsoft's software as a service solution for life, the universe, and everything. If you've heard the news, you might be asking yourself, hey wait, isn't Azure Synapse Analytics supposed to do all this already? So what's happening here? Well, let's talk for a moment about Synapse and how it all leads into Microsoft Fabric. But before we go to that, a quick note. I really don't like the name Microsoft Fabric. I think there are going to be problems searching for information given that Service Fabric and App Fabric also were products, and frankly, Fabric doesn't remind me of databases. It reminds me of bears selling softener. But that's the name, so I'll deal with it and probably not grouse about it anymore in this video. So back to the original point. Azure Synapse Analytics is a platform as a service offering for data warehousing and advanced analytics scenarios. Synapse itself is made up of a large number of components. You have dedicated SQL pools, which provide massive parallel processing for classic data warehouses. The serverless SQL pool, which allows us to query files in a data lake using T-SQL. Spark pools allow us to run Apache Spark jobs against data in a data lake. Data Explorer pools provide us access to the Kusto query language and serve best as event tracking systems, which, by the way, often includes logging solutions. Synapse Pipelines is an implementation of Azure Data Factory, allowing us to build ELT pipelines to move data into, around, and out of our Synapse workspaces. Also, there's Synapse Link, a series of no-code change data capture solutions for integrating with other products like Cosmos DB, Dataverse, SQL Server 2022, Azure SQL Database, and Azure SQL Managed Instance. Azure Synapse Analytics is a big space for us to work in, which is a blessing and a curse. The blessing is I can solve a lot of problems without ever having to leave the confines of my Synapse workspace. I have a quick read data warehouse at very large scale, there's ad hoc query analysis on my data lake, all the data transformations I need to turn outside data into clean data for analytics, and can even handle streaming data from events. But the curse is that there are clear lines delineating the products. For example, given the four pools that I talked about, the dedicated SQL pool, serverless SQL pool, Spark pool, and Data Explorer pools, we store data in 3 separate formats and in 3 separate locations. It's going to take extra code and effort to get the dedicated SQL pool to access data in a Data Explorer pool, for example. And usually the answer we land on is, well, just have multiple copies of this data passed around between systems. That increases the complexity of our solutions and introduces cases where a system that reads from the dedicated SQL pool may get one answer, but a system reading from the data lake via Spark pool might actually get a different answer due to data latency, bugs in ELT processes, or misinterpretations of business rules by different groups of developers. The other key problem is that you have to be a bit of a polyglot to make use of a Synapse workspace. I put together an 8-hour training showing how to secure an Azure Synapse Analytics workspace, and that didn't even cover Data Explorer pools. Getting the different components to talk to each other and work with the outside world is fairly easy, until you want to implement security. Then it becomes a lot trickier. So this leads me to Microsoft Fabric. Unlike Synapse, Fabric is a software as a service solution, meaning that Microsoft manages the hardware and the platform, and we're users of the platform rather than the administrators of it. This eliminates a large part of the second problem. We don't have to figure out how to let these services securely talk to one another because Microsoft has done that for us already. Our systems administrators and database administrators have a lot less to do as a result, at least in that space, so they can focus on getting the parts that we do control correct. And Fabric also has a great solution for my first problem: OneLake and a common data format. OneLake bills itself as OneDrive for data. You store your data in one location and access it from any other service. This obviates the need to make a copy for this service and a copy for that service and another copy for this other service. All of your data lives in your OneLake. This is great for a few reasons. First, you're not paying extra money for storing additional copies of that data. Second, if you want to apply security rules to the data, you can do some of this at the OneLake level, and all of the applications which access the data will automatically need to follow those rules. For example, let's say you have sensitive information that only a particular team should be allowed to access. You're able to set up rules saying that only this team is allowed to access the data based on Azure Active Directory role. Then it doesn't matter how the person tries to access the data. Could be from a T-SQL query, a KQL query, a Spark job, Power BI, whatever. Those downstream tools only see what OneLake lets them see based on the user's access rights. Inside OneLake, you have control over how you want to organize the data, so you can have multiple data lakes inside your broader OneLake design. This means that your organization has a single OneLake, but that within that, you can set up domains and workspaces. If you're big into the data mesh pattern, for example, you can implement it fairly easily with OneLake. But the thing I really like about this solution is that all of the data is in a common data format, Delta format. Delta format is based off of Parquet, a columnar file structure which is great for compressing large amounts of data. If you're familiar with column store indexes in SQL Server, the concept is similar, even if the implementation is quite different. Parquet has become the de facto standard for data lake storage, and the Delta format is essentially Parquet with the ability to track data changes using what is essentially a transaction log. The answer is really good for 3 reasons. First, queries against files in Delta format tend to perform really well, and Microsoft has some techniques for speeding up Delta file analysis in Microsoft Fabric to make queries even faster. Second, and even more important, this is an open format, meaning you don't need to use their tooling, and if you ever want to exfiltrate your data from their systems, you'll have plenty of tools and programs which can read the format. I respect the lack of lock-in. And the third reason it's great, it means we don't need to separate data storage for a dedicated SQL pool, a serverless SQL pool, and a data explorer pool. We have one format, and all of the tools are using that one format. By the way, before anybody panics, I do want to note that yes, you can import data from other formats. You can bring in delimited files, JSON files, binary data like videos and images. They'll work just fine in OneLake. But the main motif is to transform that raw data, at least for structured data sets like CSV files or JSON, transform that into Delta format before all of those downstream tools make use of the data. There are some other practical differences between Synapse and Microsoft Fabric. One of the big ones is the billing model. Synapse has an interesting billing model. You pay for service utilization. For example, if you have a dedicated SQL pool, you're paying for storage per gigabyte per month and compute as long as that thing isn't paused. For your data lake, you're paying for storage per gigabyte per month. Now for the serverless SQL pool, you pay for data processed during queries. For Spark pools, you pay for compute as long as the nodes are operational. And figuring out what your Synapse pipelines bill will be can be quite complicated, as you need to know how many pipelines you have, how long they'll take to run, what kinds of components they use, and whether you need to make use of on-premises gateways. By contrast, Fabric has a much simpler billing strategy. They bill on consumption tier, similar to Power BI Premium. Pay some amount per month and you get a certain level of performance. Want more performance? Pay more, get to the higher tier. This strategy can appeal to organizations looking for cost certainty, though people at the extreme low end of the curve who are great at micro-optimizing Synapse costs might need to pay a little bit more. We've talked a little bit about OneLake and pricing strategy, but Microsoft Fabric is a lot more than that. The problem is, this is a big space. Basically, all of your warehousing, business intelligence, and analytics. Trying to interpret all of it at once is a challenge, so Fabric uses the concept of lenses to focus on what people in a particular role see based on what they're most likely to care about. The intent of lenses isn't to prevent you from using a part of the system, but rather to emphasize the things you're most likely to use. You can always switch between lenses and get the rest of the story. Let's take a look at the happy path for one of these lenses, data warehousing. We start with our data sources, which can be structured or unstructured data sets. We run these through Fabric pipelines and data flows, similar to what we can do with Azure Data Factory or Synapse pipelines. From there, we can load the results into our data warehouse, which we're able to access from Power BI, from SQL Server Management Studio, Azure Data Studio, and more. Under the hood, our data is stored in Delta format, even if it comes back looking like a T-SQL result set. This scenario is also quite similar to the second one I'm going to highlight, the lakehouse. If you are not familiar with the concept of a lakehouse, this is something Databricks came up with a few years back. The idea is to use a central data lake for all of your data processing, instead of having your data held in different services. At the time, I had said that this was a really neat idea, but it would take about 4 to 5 years to become practical. In essence, this is the promise of Microsoft Fabric as well. A single location for your data and tools to expose that data in ways that users are most comfortable with. Here's the scenario for building a lakehouse. Like with our data warehouse scenario, we start with our data sources and perform ingestion, either through pipelines and data flows or by using shortcuts. Shortcuts are the one-leg equivalent to shortcuts in your file system, symbolic links to data stored in some other location. You can use shortcuts to expose the same data to multiple data lakes and lakehouses without needing to make copies or risk different teams working with different versions of files. I think shortcuts are going to be relatively more important for large enterprise customers, but regardless of your organization size, this is a nice concept. When storing data, we once again keep everything in Delta format, and we can use notebooks to run Spark jobs against that data, or we can execute data flows to reshape the data into the format we need. We can access the data from Power BI, database tools, or anything which reads Delta format. So this scenario is going to fit right into the data engineer's wheelhouse. For data scientists, here's a separate scenario for you. In this case, we are building off of what the data engineers have done in preparing lakehouses and data warehouses. Then we can clean and prepare data using Spark notebooks and use common ML packages in Python and R to train models and generate predictions. As a quick note, the Microsoft Fabric data science and machine learning scenario keeps us in Fabric rather than using Azure Machine Learning as the central hub for ML. This is similar to the early days of Synapse, so we'll see if things evolve like they did in Synapse, or if we do keep data scientists locked into Fabric. The last scenario I want to talk about is real-time analytics. Real-time analytics covers a variety of scenarios, but the short version is that we have events coming in, typically using something like Kafka or Event Hub, and we want to ingest those events. We can bring in ML models and supporting information from lakehouses or datasets. This data makes its way into a Kusto database, which is quite similar to Azure Data Explorer or the Data Explorer pool in Synapse. Now, this data is not in Delta format, but there is a mirror written to our lakehouse, which is in Delta format, meaning we get the benefits of built-in caching and indexing from Kusto while still being able to work with that data in other tools. The normal path, however, involves running queries in the Kusto query language, either as scripts or in notebooks. Or you can use Power BI. You might have noticed Power BI show up over and over, and that's because it's an integral part of Microsoft Fabric. The end goal of an analysis project is to provide relevant insights to end users in a way that they can understand, and Power BI is an excellent tool for that job. Almost everything in the product is geared toward making it easy to get to the end goal of visualizing data in as few steps as necessary. One last thing you might be wondering with this announcement is, what's going to happen to Synapse? Do we have to move away from Synapse right now? The short answer is no. Azure Synapse Analytics will still be around. Microsoft has announced no plans to deprecate the service, so if you're using Synapse today and you like it, there's nothing compelling you to move on. That said, for new projects, I would highly recommend Microsoft Fabric instead of Synapse once Fabric leaves public preview, and do try it out while it's in preview. Fabric is where we know new functionality will come in, and it's a key part of Microsoft's business plan going forward. There currently aren't any migration tools available to move from Synapse to Fabric, but we'll see what enterprising organizations come up with over the next several months. This has been an overview of Microsoft Fabric. The announcement just dropped today, so let me know what you think in the comments. Have you tried out Azure Synapse Analytics before? Are you using it today? Does Fabric look interesting? Do you hate the name as much as I do? We'll have links and show notes in the description below. And until we see each other in the next video, take care.